I'm going to work through study guide questions here. This is for the second part of the exponential and log functions. So when we have log equations, this is actually one of the first things that we had done in this second half. Remember, we can drop the logs as long as those bases are the same. If they weren't the same, that would be a very different thing. And then we're just going to solve the equation that results. So we're going to move those x's to the left. I'm going to move the constant to the right by subtracting 7. And then I'm going to divide by 3. Right? So you might have done this. And then on another step, this. Keep in mind, this is a review, so this isn't really to teach you how to do it. It's just so you can check what you work on. So I'm probably going to leave, not give us quite as much detail in this video. Again, this is the study guide. Exponent, right? And then this is going to get divided. So we're going to do our condensing. We're going to condense over here. 20 divided by 5. Now we can drop those logs because there's only one on each side. It's called the one-to-one property. And now we're going to multiply out y plus 5 times y plus 5. So even though I said I wasn't going to show every step, it's worth showing that y, this is not, it is y squared. There will be a 25 out here, but please don't forget that we also have y times 5 and 5 times y. So we have 10y in the middle. And then over here, 20 divided by 5 is just 4. 4 is going to need to slide on over there because we have a quadratic, right? We have a second power. So now y plus 3, y plus 7, right? What multiplies to be 21 and adds up to 10. So this is going to give me y is negative 3, y is negative 7. Remember, we should always check for extraneous solutions. If I plug that back in to the argument that includes a y, which is right here, negative 3 plus 5 is positive 2. We're good. But negative 7 plus 5 is negative 2. Sorry, you're extraneous. We're not keeping you. Okay, so next part here. Now we have only one log, right? There's only a log on the left side. So this is when we're going to change to exponential form. So our base is 2. Our exponent is the 7. So 2 to the 7th. You could put your argument, your 9m plus 2 on either side. Remember, that's not 2 times 7. It is 2 to the 7th power, which I believe is 128. And then we can subtract 2 and divide by 9. And that certainly would make a positive number for the argument. So we're okay. All right, so that's the log equations that we skipped over when you worked on the study guide before your last quiz. And then there are some some practice problems on the back page. So this should be, at least this term, this is the very back page. And we have some space up here for writing So exponential growth, remember this is when we had our amount is our principal, or we might have used A there plus R to the T power, and decay. And again, oh, we did use A. I see it now. So we used A. And over here, we just said like Y. So Y equal, sorry about that, A 1 minus R to the T. And then we learned about compound interest. And now we're going to use P for the initial amount. And we could still say Y equal, or we could say A for amount. But the principal 1 plus, because we're earning interest, but then it's going to get divided by the number of compounding periods in a year, and then it's going to get raised to that number times the number of years power. So in number 41, our current number, I see it's decreasing, so this looks like exponential decay. Our current number is 250,000. You can include the comma, just remember don't try to type that into your calculator. And we're going to subtract 1.5. Again, make sure that that 1.5 is changed to a decimal, so 0.015. You can have another 0 over here if you'd like, but this should look like 0.985. And then the time, 25 years. All right, so there's your setup. These are birds, so please, whole number of birds. We don't want any partial birds. So I might say in 25 years, there will be blank number of birds. $42 increased in value. So we know value is going up, so this one is an exponential growth. So our initial amount, $200. We're growing by 7%, so that's 0.07, so we can add that to 1 pretty easily. And then what about our time? So from 1980 to 2016, so you're going to do a little subtraction. So that would be 36 years. So 36 is what we'll actually use as the exponent. And then we can say the value of the card is, since 2016 is, past now, so many dollars and so many cents. Okay, so since it is money, it is appropriate to round it to 2 decimal places for dollars and cents. Alrighty then. And if you're working on this and I'm not around, after you get that set up, I think you all are pretty capable of typing that in, but check with a friend, see if you guys are getting the same situation, the same thing. Bi-monthly. Bi-monthly means every 2 months. Semi-month means 2 times in 1 month. Bi-monthly means every 2 months. Just like some people get paid bi-weekly, they don't get paid twice a week, they get paid every 2 weeks. So this is 2 months. So how many times would that be in a year? 6 times a year. So 6 is actually our n number. So this one's got our principal. We're going to find out the total amount in the account after 25 years. We're starting out with $2,400. We need that 1 in there. That's like maintains our initial investment. 1.8% would be 0.018. That needs to be divided by 6 because 6 different compounding periods a year. And then our power is going to be 6 for the number of times per year times 25. So you could put all that in the calculator, but before you put things in the calculator, in this case, 0.018 divided by 6 is nice and clean. 0.003, not just 0.03, that would be 3%. That'd be too much. And then 6 times 25, our power is going to be 150. Okay, so I could say the balance of the account will be, again, dollars, cents. And then number 30 is pretty similar, except this time we are compounded quarterly. So that means that n is 4. So we're still using the compound interest formula. So the amount, and then we also have a little extra something here because it says find the amount of interest. So we need to find the total amount, and then after we have the total amount, subtract the principal to get the interest. You're going to have a little extra something there at the end. Let's make sure we can get this part set up correctly. 30,000, that's my principal. 1 plus 0.04 divided amongst those 4 quarters, and then 12 years, so 4 times 12. Remember, that's always the trade-off, is if you have something here, you're going to have something here. And then if it comes out nice and neatly, then we can clean it up before we put it in the calculator. If it's like a whole bunch of decimals, especially if there's big numbers like this 30,000, you want to like put the whole thing in the calculator so you don't lose any accuracy. In this case, 4% divided by 4 is just 1% each quarter, and then we can raise that to the 48th power. So whatever this answer is, we're going to say blank, subtract 30,000 is going to equal the interest. The bigger number that you're going to get is the total amount in the account, not just the interest. So we could say Sarah earned blank dollars and cents in interest. Or you could say the interest is or would be or something similar to that. All right, so those are the study guide questions. And then you also have the review probably to work on, at least if this is September of 2025. And we will be going over that review before your quiz. All right, thanks guys.